In the figure 1.55, angle BAC is equal to 75 degree. Next, angle EDC is equal to 75 degree. So state which two triangles are similar by which test. Also write the similarity of these two triangles by a proper 1-to-1 correspondence. So students, first of all, we have to take triangle. First smaller triangle will take this part, okay, and then the bigger triangle will be taking. Okay, so bigger triangle means this full part. Okay, now students, keep it in mind, every time your triangle name should be in proper correspondence, right? So here naming how I'll be taking, first 75 degrees already there. Next is C angle is common to both the triangle. So naming I'll be writing in this manner. In triangle C, that means common angle, D 75 degree, and E the angle which nothing is given. And triangle same way, in bigger triangle common angle is C, then B 75 degree, and they which is and A angle which is not given anything. So first we'll write common angle, that means angle DCE is congruent to angle BCA. Reason, common angle. Next is D angle will be taking. So D is congruent to B. So angle CDE is congruent to angle CBA. Reason, each 75 degree. Therefore, triangle CDE is similar to triangle CBA by a test of similarity. Now, in the question it is given, state which two triangles are similar. We proved already, and by which test? We got by a test. Now, we have to write in proper correspondence. So, in the given question itself, we had written it in correspondence. So, correspondence we can write like this: CDE corresponds to CBA. Are the triangles in figure 1.56 similar? If yes, by which test? Now solution. So here in the given question only the value of sides are given, right? So if we show the sides, the ratio of the sides as equal, then these two triangles will be similar. So for that we'll write, in triangle PQR and triangle LMN, first we'll find the ratio of all the sides. That means PQ upon LM, it is equal to 6 upon 3. 3 2s are, 3 1s are. We'll take this as equation number 1. Next is QR upon MN. It is equal to 8 upon 4. That means 4 2s are and 4 1s are. We'll take this as equation number 2. Next is PR upon ln. It is equal to 10 upon 5. 5 2s are 10, 5 1s are 5. So this is our equation number 3. Now from all the given 3 equation, that is equation number 1, 2 and 3, we get PQ upon LM is equal to QR upon MN. It is equal to PR upon LN, right? So here all the three sides are in ratio and that is equal. So therefore triangle PQR is similar to triangle LMN by SSS test of similarity. As shown in figure 1.57, two poles of height 8 meter and 4 meter are perpendicular to the ground. If the length of shadow of smaller pole due to sunlight is 6 meter, then how long will be the shadow of the bigger pole? Solution. Let PR be the smaller pole and QR be its shadow. Similarly, let AC be the bigger pole and BC be its shadow. Now, both the triangle we have to prove similar first, right? So, in triangle PRQ and triangle ACB. Now, both the angles will be perpendicular. That means angle R and angle C. So, angle PRQ is congruent to angle ACB. Reason is each 90 degree. That means pole is always perpendicular to the ground. Now next is this angle, right? So this angle will be congruent. Why? Because shadows cast at the same time, right? So angle QPR is congruent to angle BAC. Reason, shadows cast at the same time. Therefore, triangle PRQ is similar to triangle ACB by AA test for similarity. Now we will write its sides in upon form. That means we can write therefore PR upon, here PR we took, so from the other triangle it is AC. PR upon AC will be equal to QR upon BC, right? And reason is CSST, that means corresponding sides of similar triangles. Now we will put the value. So the value for PR it is 4, the value for AC it is 8, the value for QR is 6 and the value for BC is X. Therefore 4 into X is equal to 6 into 8. Therefore, x is equal to 6 into 8 upon 4. So, 4 ones are 4 twos are, right? So, therefore, 6 twos are, it is 12. So, the unit in the given question, it is meter, right? So, we can write as x is equal to 12 meter. So, the final answer we can write, therefore, length of the shadow of the bigger pole is 12 meter. In triangle ABC, AP is perpendicular to BC, BQ is perpendicular to AC, B dash P dash C and A dash Q dash C. Then prove that triangle CPA, right? Now CPA is this triangle CPA, right? And next is triangle CQB. So CQB is CQB, this part, right? So now we in the question it is given the value for AP it is 7. So here the value for AP is 7. Next BQ it is 8. Next BC it is equal to 12. So we need to find the value for AC. So AC will be question mark. Now solution. First we will prove both the triangles similar. So in triangle CPA and triangle CQB, now both are having each 90 degree, right? So that means in CPA P is 90 and Q is 90. So angle CPA is congruent to angle CQB. Reason is each 90 degree. Next is we can check out C is common angle, and in the triangle name also we can check out. So this is C and C, same letter in the same place. That means it is common angle. So its name we can write angle PCA is congruent to angle QCB. Reason common angle. Therefore triangle CPA is similar to triangle CQB by a test for similarity. Now, if the triangles are similar, we can write the sides in upon form. That means CP upon CQ is equal to next second third. That means PA upon QB, next first third. That means CA and CB. Reason is CSST. Right? Now, in the given question, the value for AP is given, BQ is given, BC. So we need to find is CA. So that means this part we don't need. So we can write as therefore PA upon QB is equal to CA upon CB. So we'll just substitute the values. So the value for AP is 7, QB is 8, CA we need to find CA, that means AC, and BC value it is 12. Substituting the values. Therefore AC is equal to 7 into 12 upon 8. 4 2s are 4 3s are. So AC is equal to 21, 7 3s are 21 upon 2. Therefore AC is equal to, after dividing we will get 10.5 units. This is our final answer. In trapezium PQRS, side PQ is parallel to SR. So here PQ, this PQ is parallel to SR. Next is AR is equal to phi AP, AS is equal to phi AQ. Then prove that SR is equal to phi PQ. To prove, we need to prove is SR is equal to 5 PQ. That is, we need to prove SR upon SP is equal to phi upon 1, or you can even say SP upon SR is equal to 1 upon 5. Okay, solution. Now, trapezium PQRS, right? So, quadrilateral PQRS is a trapezium. Now, therefore, PQ is parallel to SR. Therefore, angle PQS, say students, this angle PQS is equal to angle QSR, is congruent to angle QSR, right? So this is, reason is alternate angles, and this we can give as equation number 1, right? Next is this two vertically opposite angles we will take in the triangle. So we'll take two triangles. In triangle PQA and triangle RSA, right? So first we already got as PQS is equal to QSR, right? So but according to the triangle we will take PQ instead of S we will take as A is congruent to angle RSA from 1. Next we will take vertically opposite angle. Angle PAQ is congruent to angle RAS. Reason is vertically opposite angles. Therefore, triangle PQA is similar to triangle RSA by AA test for similarity. Therefore, PQ upon RS is equal to QA upon SA is equal to PA upon RA. Reason is corresponding sides of similar triangles, right? So now we need to find SR part, right? So SR part, that means first wala part we want. Next is AR. AR means this part. Second part no need to write. So PQ upon RS is equal to PA upon RA. But you can see in the question here it is given AS is equal to phi AQ, right, and AR is equal to phi AP. So this AR, instead of AR we can write 5 AP from the question, right. So PQ upon RS is equal to PA upon 5 PA. AP means PA. So this both gets cancelled. Therefore, PQ upon RS is equal to 1 upon 5. So cross multiply 5 PQ is equal to RS. That is RS is equal to 5 PQ. Hence proved. In trapezium ABCD, side AB is parallel to DC. So AB is parallel to CD. Now next, diagonals AC and BD intersect in point O. The value for AB it is 20. We will write here as 20. Next, DC is 6. OB is 15. And we need to find this part OD. We do not know. Right? Now, before moving with this sum, we know that we will get the value of OD by writing the values in ratio, right? So, but we also need to understand that if we want to write it in ratio, the triangle should be similar. So, triangle similar is not given in the question. So, first we will prove the triangles as similar, right? Now, we will take this triangle COD and AOB triangle. Let me mark this triangle and this triangle, right? Now in this triangle only one part we know, that is vertically opposite angle. So other part, one more angle we need, that we do not know, right? So we will get how. Let's continue. So in trapezium ABCD, side AB is parallel to side DC, right? Now, if it is parallel, then alternate angles will also be equal. That means this angle and this angle will be equal. So, we can write as angle CDB is congruent to angle ABD. But we are limited to triangle only, right? So, that is we can write as angle CD instead of B we can write as O is congruent to angle ABO. This we can take as equation number 1. Now we will go move on with the triangle, right? So triangle name is in triangle COD and triangle AOB. Dear students, every time you have to understand, whenever you are taking a triangle, your triangle name should always be in one-to-one correspondence. So here first O we already know. Here D extra we have written for alternate angles. So reason here we can write as alternate angles. So first we can write angle COD is congruent to angle AOB. Reason, vertically opposite angles. Next is angle CDO is congruent to angle ABO we received from equation number 1. Therefore, triangle COD is similar to triangle AOB by AA test for similarity. Now we'll write in ratio form, that is first second position, that is CO upon AO, then second third position it is OD upon OB, first third position that is CD upon AB. Reason is corresponding sides of similar triangles. In question the value of AB is given, DC, OB, and we need to find is OD. That means there is no need of this ratio, that is CO upon AO. So we will skip it. So OD upon OB is equal to CD upon AB. Now putting values we'll get, instead of putting you can write even substituting. So OD value we need to find, OB it is 15, CD it is 6, and the value for AB it is 20. So after cross multiplying we get OD is equal to 6 into 15 upon 20. 5 3s are 5 4s are 2 2s are 2 3s are. So therefore OD is equal to 3 3s are 9 upon 2. Therefore the value for OD is 9 upon 2 is equal to 4.5. So final answer we can write as OD is equal to 4.5 units. This is our final answer. Quadrilateral ABCD is a parallelogram. Point E is on side BC. Line DE intersects ray AB in point T. So prove that DE into BE is equal to CE into TE. Right? Now solution. Quadrilateral ABCD is a parallelogram, right? So if it is a parallelogram, we know that opposite sides of a parallelogram are parallel, right? So BA will be parallel to CD, right? Therefore seg BA is parallel to seg CD, right? Now this is parallel, that is we can even write seg BT is parallel to seg CD, right? This is BT. Now these two are parallel, right? So we will get alternate angles as equal, right? So these two are parallel, so according to Z shape, so we will get these two angles are as congruent. Therefore we can write angle BTD is congruent to angle CDT, that is angle BTE is congruent to angle CDE, right? Now we'll move on with the triangle. So triangle name always you should write in correspondence, right? So in triangle B, then alternate angles T, then vertically opposite E, and triangle C, alternate angles is D and vertically opposite is E. Therefore angle BTE is congruent to angle CDE. So this we can write here as 1 and reason as alternate angles. So this we can write from 1. Next is angle E is vertically opposite, right? So we can write as TEB, second, third, first is congruent to angle DEC. C. Reason is vertically opposite angles. Therefore, triangle BTE is similar to triangle CDE by A test for similarity. Right? Now students, we got test. Right? Now we will have to write it and upon form, that is ratio. So therefore, first second, that is BT upon CD, is equal to second third, that is TE upon DE, first third, that is BE upon CE. Reason, corresponding sides of similar triangles. Right? So we'll check out the question here. We need DE. DE is here. Next BE. BE here. Next CE. Next is TE. Right? So we don't need this first part. So we can write therefore TE upon DE is equal to BE upon CE. Now we will cross multiply. Therefore, TE into CE is equal to BE into DE. Right? That is similar way as it is in question. We will write DE into BE is equal to CE into TE. This is a final answer. Hence proved. In the figure, seg AC and seg BD intersect each other in point P. So, and AP upon CP is equal to BP upon DP. So, we have to prove that triangle ABP is similar to triangle CDP. So, first we'll take the triangle as it is in triangle ABP and triangle CDP. Now here in the question it is already given AP upon CP is equal to BP upon DP. So this reason we can write as given. Now we can see from the figure it is vertically opposite angle, right? That means angle P. So we can write that angle APB is equal to or congruent to angle CPD. Reason is vertically opposite angles. Now, two sides are there and in between angle is given, right? So, therefore, triangle ABP is similar to triangle CDP by SAS test for similarity. In the figure, in triangle ABC, point D is on side BC such that angle BAC is equal to ADC. We need to prove is CA square is equal to CB into CD. Right? Now, solution. We'll take two triangles, that is the first smaller triangle ADC. In triangle ADC, right? So I have already told you all we need every time to write the triangles in one-to-one correspondence, right? So here A is nothing, right? D is already given angle and C is common angle, and the bigger triangle will take as B, then given angle that is A and common angle is C, right? So first in the given question it is already given BAC is equal to angle ADC, so we can write as angle B, not BAC, we can write as ADC, right? Why? Because ADC triangle we had written first. So angle ADC is congruent to angle BAC. This is given. Next is common angle. Angle DCA is congruent to angle ACB. Reason is common angle. Therefore, triangle ADC is similar to triangle BAC by AA test for similarity. Therefore, AD upon BA is equal to DC upon AC is equal to AC upon BC. Reason is corresponding sides of similar triangles. Now we'll check out the question again. CA we need 2 times. That means CA is here, AC and AC. Next is CB and CD, CB and CD. So we don't need this part. So we'll write DC upon AC is equal to AC upon BC. Therefore, after cross multiplying, we get DC into BC is equal to AC square, right? So, before this step, you can even write like this: DC into BC is equal to AC into AC. So, this becomes AC square. So, according to the question, we can write as CA square is equal to CB into CD.